Chapter 1 deals kind of strictly with recursion, and understanding recursion helps you understand where a lot of math formulas come from. So for example, you maybe in the past in Algebra 1 dealt with the arithmetic formula for the nth term, or the geometric formula for the nth term, or even some, formulas for compound interest and things like that. Well, we're going to learn recursively this chapter to help us understand where those formulas actually come from. So recursion in general is just like a process where each step of a pattern is dependent on the step or steps that come before it. So it's like a repeated process, right? And in math, usually recursion we deal with sequences. Okay, and we're going to deal with two types of sequences right away in this first section: an arithmetic sequence and a geometric sequence. Those are the two types we're going to look at. Yeah, there's just one difference between the two. One's adding and the other one's multiplying. So let's deal with our arithmetic sequence first. So in arithmetic sequence, each term is equal to the previous term plus a constant, plus a number. Really, you just add or subtract by the same number. The definition says plus just because subtracting is the same thing as by adding a negative, right? You add a negative. That. So let's look at an example here to make sense of this. So here's a sequence where it's adding by the same constant each time. 4, 7, 10, 13, 16. And most of us can see that it's going up 3 each time, right? Plus 3, plus 3. We call that the common difference. And if it's hard to see, I can tell just by looking at that. To find the common difference, you take any term in that sequence and subtract by the previous term. So I go 16 minus 13, that equals 3. And we use the letter D for common difference. Small case, so D equals a positive 3. For the first term, it's always good to know what the first term of the sequence is. That's very helpful. And we use this symbol U sub 1. I say sub 1 because it's a subscript. We call this 1 when it's lower, a subscript. And so when I say U sub 1, I mean it's like a small 1 below the U. So U sub 1 just stands for the first term. That equals, well, what was our first term? 4. So U sub 1 is 4. So 1 stands for the first term. Sometimes, depending on the situation, they might use 0, U sub 0 for the first term. Okay, it might be one of the two. In general, so if we're not dealing with a story problem, most of the time we're just going to use U sub 1 because 1 is the first term. It's easy to remember that way. Yep. So we call the number or the value in our sequence U's. So if I look back up top here, we just said 4 was U sub 1. That's the first term. Well, the second term is U sub 2. Okay, so if I said U sub 5, that means it's the fifth term. So 1, 2, 3, 4, fifth term. So U sub 5 would equal the value of 16. Okay, that's what we use those U's for. It just stands for the value of what spot it's in. That's the fifth spot. Okay? All right, let's actually write a recursive formula for this sequence. So the key is there's 3 statements needed to define a recursive formula. So I'm going to put 1, 2, 3, just to make sure that we got all 3 statements. Okay? And now I'm going to put some stuff on the side to make sense of things. The very first thing that we do, we always write the first term. Always write the first term. And I wanted an equation, so I need to say U sub 1, right, that's the first term, equals 4. So I'm just going to state the first term. Always state the first term. Sometimes it could be U sub 0, but most of the time it's going to be U sub 1. Okay? The second thing is, we're going to write an equation for the nth term. Okay? And like I said, you probably learned in Algebra 1 an actual equation that finds the nth term no matter what you plug in for n. We're going to do things just a little bit different. Okay? So let's take a look at this. So I started with the first term, right? That was my first term. So U sub 1 equals 4. Well, if I wanted to find U sub 2, the next term, what do? I take the term before and I added the common difference. Remember the common difference was 3 in this case? So then the same thing would happen. So U sub 2 equals 7, correct? right? And then I could go u sub 3, take the previous term, which is 7. But instead of writing 7, I want to write something in place where I always know it's the previous term. Just pretend like if I don't know what value it has. So what could I say? I could say u sub, well, it's the second one, right? It's the one before 3. It's really u sub 2. Okay, and then I would add 3 to it. But now if I didn't know which spot I was dealing with, I didn't know I was dealing with like the third spot and the second spot, how could I replace that? Well, instead of saying u sub 3, I'm going to say u sub n for the nth term, right? And what do? We take the term before it, the previous term. So how could I use that in terms of n to represent the previous term? Well, if I look, this was the third term, and I'm taking the term before it, right? I took the second term. So I need to say u sub, well, if this was 3 and this ends up being 2, it's the one before. So it's really n minus 1. U sub n minus 1. That represents the previous term. And then we would add 3 to it, right? Because that's our common difference. So that is my equation for the nth term. So u sub n, we always say u sub n for the nth term. Well, it's the previous term. That's how we represent the previous term. Plus 3, our common difference. So that should be able to work out. If I plug in, so let's say I wanted to find the fifth term. I would say 5 minus 1 right there, right? So u sub 5 would equal u sub 4, and u sub 4 was what? 13 up top, so I'd say 13 plus 3, so u sub 5 equals 16. I know sometimes you might think, well, that's kind of a waste of time. I can see that. But we're just getting used to writing that recursive formula. And then our last thing that we say is, it's not going to work for every single number for n when I plug it in, right? So I'm going to say, when n is greater than or equal to, well, what numbers wouldn't work if I think about that? If I tried to plug in a 1 in for n, that would get 1 minus 1 right here. That would be u sub 0. Well, I don't have, there is no u sub 0 up here. There's no u sub 0, right? So that does not work. I can't plug in a 1 for n. I could plug in a 2 for n though, right? That would work, because then I'd get u sub 1 right there. And I do have a u sub 1. So I know that I can't plug in a 1, but I can plug in a 2. So I'm going to start when n is 2 and go above that, right? I can go 2 and greater. So hopefully that wasn't too confusing. Basically all that happens is whatever you state for your first term, your statement at the end, you'll just put when n is greater than or equal to, and you just do the number that's next, right above whatever your first term was. So if it was 1, this would be a 2. If this was a 0, this would be a 1. Okay? It's pretty straightforward once you get used to it. Now we're going to be given a recursive formula, and we want to write the first 4 terms of a sequence. Yeah? And hopefully just by looking at this, you should be able to figure out the quickest way to do it. So 47 is my first term, right? My first term. Now it's my recursive formula. The nth term is the previous term minus 3. So it's going down 3 each time, right? And then where n is greater than or equal to, well, it's always the one above the first term, which is 2. So I just did the very next one. So really all I have to do is keep subtracting 3. So 44, 41, 38, 35, there we go, next 4 terms. So that's the easy way to do it. So now we're going to write a recursive formula, and then we're going to find the indicated term. So this states our sequence, and then it says find the 14th term. Find the 14th term. So first of all, you always start by finding the common difference. Okay? So you take any number and subtract the number previously. So I actually did that on my calculator here. And I got 3.29. So I know that the common difference is 3.29. So before we do anything, let's start writing our recursive formula. Remember, it takes 3 steps. So first step, write the first term. So I'm going to say u sub 1 equals 1.56. Second step, always u sub n equals, remember the previous term, so u sub n minus 1. And then what are we doing? We're going up, so plus 3.29. Remember, just the common difference just goes right in there. And then we always state the third term, we say, when n is greater than or equal to, we'll just 1 above whatever we use for the first term. So we use 1, so I go 1 above it, which is 2. So there's my recursive formula. Okay, so, and the quickest way now to find the 14th term is to use your calculator. And I'm going to show you how the quickest way to do this. So if I pop this up, I found that the common difference is 3.29. So I'm going to retype my first term, which is 1.56. And then we're adding 3.29 each time. So that gives me my second term. There's my second term. Okay? To be able to just hit enter over and over and over and keep adding 3.29, what we need to do is we need to take the answer that we just got and add 3.29. So what I can do is I can just immediately hit plus, and it'll put in A and X. That stands for the last answer you just got. And I'm going to add 3.29 each time. So now you just have to keep track of it in your head. You could write these down, but if you keep track of it in your head. So now I'll hit enter. There's my third term, fourth term, fifth term, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th term. So there we go. So I'm going to say u sub 14. So I'm going to say u sub 14 equals 44.33. Okay. Well, the other thing is the geometric sequence. The only difference, we'll kind of fly through this, is that we're multiplying. We're multiplying. Okay? It could be division, but really when you divide, you're really multiplying by the reciprocal. Right? So that's why we always just say you're multiplying. Okay? So whenever it goes down, like if you had a sequence that went like 16, 8, 4, 2, it's really dividing by 2 each time, but we would say the common ratio is 1/2 because you're multiplying by 1/2, right? It's just the opposite reciprocal. So in this case, the common ratio is, well, to find whenever it's being multiplied, and you should look, don't just automatically subtract. Like if you do this and you subtract, always check, will I get the same subtract or common difference if I subtracted those? No, you don't. So you know it's geometric. So now we would divide instead of subtract. So I can take any number and divide by the previous. So I'm going to take 8 divided by -4, which I get -2. I could have done that anywhere. I could take a -64 divided by 32, and I still get the same thing. So we'd say R is -2 in this case. So now our u sub 1 that's our first term, right? So that's -4. So let's quickly write a recursive formula for this. And we'll see what the difference is. So first step, state the first term. U sub 1 equals -4. Second step, write a equation. U sub n equals the previous term. Remember we always do u sub n minus 1. Well, instead of adding or subtracting or adding every time, now it's multiplying. So now we just multiply, so we can just put a dot or parentheses and -2. And what the book usually does, they'll flip those around. They'll say u sub n equals -2 times u sub n minus 1. I'm okay either way. And the third step, when n equals, or is greater than or equal to, well, we use 1, so 1 greater 2. Done. Last thing, let's look at an example here quickly. So a car leaves town heading west at 57 kilometers per hour. How far will it travel in 7 hours? So it's kind of recursion. It's basically going up 57 kilometers each time. But really, I can just take 57 times 7 to get that, correct? So I get 9 and 399 kilometers. Just be careful with your label there. Here's the tricky part. It says the second car leaves town 2 hours after the first car, but is traveling at 72 kilometers per hour. So it's going a little bit faster. The nearest hour, when will the second car pass the first? So there we go. We got rates times distance. So we're using our mathematical dirt. Remember, D equals RT. So let's write an equation for each of those. So first car, D equals 57 kilometers per hour times the time, right? So the rate was 57. Let's write one for our second car. T equals 72 times the time. But do they have the exact same time? No. The second car left 2 hours after, which means the first car drove for 2 more hours, right? So T plus 2 for the time. That's how we're going to represent time. So instead of T, we have to add 2 hours onto the second car's time. And then, when will it pass the first? So what do we know about their distances when it passes each other? Right, here's the first car, it leaves. Okay, then the second car leaves 2 hours later. Well, eventually, they have the same distance. So what can I do with these two equations? You bet, I can set them equal. So I can say 57 times T plus 2 equals 72T. And then what we do, just solve for T. So we distribute, so 57T plus 114 equals 72T. Get our T's to one side. And you should see where this is going. So we have 114 equals 15T and divide by 15. So T in this case is about 7.6, and what was our label? Hours. And it said to about, always go back and reread, to the nearest hour. So it's about 8 hours after the first car leaves or the second? Well, it just depends on what you put. We solve for T, so that's right there. That's only the second car. So about 8 hours after the second car leaves. After second car leaves. So you got to be kind of specific there.